supposed to figure out what the graph looks like, what absolute value that each of these looks like. So 15. We talked about this a little bit the other day. Here, let me bring up my drawing tablet. So I'm not so much concerned about your ability to sketch these as to know what the function is.
Yeah.
So on that, the absolute value of f of x is just the absolute value of 2x plus 3.
Mm-hmm.
And if you were to plot 2x plus 3, it would look normally like that. And you always know that anything that's below the x-axis has to be a mirror reflection. So it needs to be that. And I think we went through most of these. We went through C. What would D be in terms of the equation for 15?
For 15?
Uh-huh.
D
f
would
of
be
2x.
D would be a vertical stretch.
No, verticals happen when the number is outside the parentheses.
Oh, so a horizontal shrink?
Yeah, but what would the new function be? In other words, if f of x is 2x plus 3, what is f of 2x?
It would be 4x plus 6.
No, you only plug in for x.
Oh, okay, so it would just be 4x plus 3.
Yeah, it's going to be 2 times 2x plus 3.
Yeah.
Is 4x plus 3, which is, if this is 2x plus 3, this is 4x plus 3, steeper, twice as steep.
Yeah.
That's the only difference between the two. So what is 2 times f of x?
That would be the vertical stretch.
Okay. What's the equation? Yeah.
That would be 4x plus 6.
That's the one that's 4x plus 6. In other words, you just multiply the entire function times 2.
Yeah.
Okay, and of course that has the same steepness but goes through a different y-intercept.
Yeah.
Okay, so that's all we're going to do with each of these. Let's see if there's any difficulties here.
I'm hung up on the f of absolute value x for 16.
Okay. So f of absolute value x merely means that whatever is in the parentheses, we're going to plug in for x.
Yeah.
Okay, so instead of x, I've got absolute value of x squared. Instead of x here, I have absolute value of x. So that's our answer. Now, what does that actually translate to? Let me think for a second on this. In other words, clearly, this is still x squared. And this is always
5x?
No, if x is negative, then it's minus 5x. And if x is positive, then it's minus 5x. So is that right? Let's look at this for a moment. Let's see. If x were minus 2, then yeah, this is right.
So it would be the same?
Yes.
Okay.
If, well, let's see, if x were positive, in other words, let's look at that for a second. Let's say what f of minus, the absolute value of minus 2 would be. Well, that's the same as f of 2, which is the same as 2 squared minus 5x minus 3. I think f of the absolute value of x is the same. No, it's not going to be the same as f of x, because when x is negative, it's not the same. Yeah, I'm 90% sure that that's the right answer.
Okay.
These are a little bit oddball questions. You don't normally see these very, very frequently, particularly in calculus. Calculus, there's nothing magical about calculus about absolute value. In fact, it's rarer that you see it in calculus than you do in precalculus. Okay. F of 2x for 16, you have any problems with that?
Yeah, would you just replace or put 2x where f of x, or wherever x is, so it would be like quantity 2x squared and then minus 10x.
I don't mind doing this initial step because it shows exactly what you're doing.
Yeah.
You're substituting whatever's inside the parentheses wherever you see x. And then whatever that comes out to be, 4x squared minus 10x minus 3 is the answer. And 2 times f of x is just 2 times the whole function. So it's 2x squared minus 10x minus 6. Let's look at the trig function. First of all, if we graph that, that's what f of x equals sine x looks like. What does this look like?
Um,
In other words, f of sine x goes to 1, down to minus 1, and begins and ends by 2 pi. So what's the effect of the 2?
Would it be a...
No different than a polynomial. Exactly the same.
So that's a vertical stretch?
Yeah. So we're going to do this. If I was doing just 2 sine x, that's what it would look like. What's the effect of the 3?
The 3 is a horizontal shrink.
Correct, which means I have to get the entire period in by 2/3 pi. I've shrunk it by a factor of 3.
Mm-hmm.
And now I have to quarter this. In other words, I know I'm going to draw the entire curve between that point and that point. So I quarter it to figure out where my peaks and valleys are. And I know it's still a vertical stretch. So at the first quarter point, I got to go up to there, come back through the x-axis there, go all the way down to minus 2 at the next quarter point, and finally back to the x-axis there. So this would actually look like this. And that's how you want to do these. In other words, they're really no different than polynomials. I don't know why the schools don't teach them that way. They tend to treat sinusoid equations as an entirely different subject. When in fact, that's a vertical stretch, that's a horizontal shrink.
Yeah.
All right, now let's look at absolute value. If I drew the absolute value of my blue curve, what am I going to do?
You're going to have, wherever it's negative, it's going to be positive.
Yeah. In other words, all of this negative right here should be reflected about the axis, and so the final curve would be everything that's above the x-axis.
Yeah.
Okay. F of absolute value of x. And this is the strange one. Well, again, we're going to plug in absolute value of x instead of x. So that would equal 2 sine of 3 absolute value of x. And whenever you have a positive number inside an absolute value, you can always take it out.
Yeah.
Like I've done.
Would it have a line of symmetry at x equals 0?
Well, I hadn't thought about it yet. I was trying to figure out what the consequences of this would be. In the regular f of x, it goes negative. In other words, it really goes like that. And now we're saying that wherever x is negative, it's actually positive.
So instead of having that dip at x equals 0, it would just or anything less than 0 would be
I'm going to
reflected.
say that anything to the left of x equals 0. Let's see, it doesn't change the right side of the curve. Everything from here to the right is no different because the absolute value of x is the same as x.
Yeah.
Okay, so my blue line stays. But now, typically, if I had the sign of minus x, that's equal to minus the sign of x. So whenever I'm in this territory, at least from there to there,
it would be equivalent to
the reflection.
Yeah, so everything to the left of the x-intercept would be reflected.
Well, let me think. Yeah, including this. In other words, exactly.
Yeah.
Like that. Because even over here, when x is negative, where y would normally be positive, which is like third quadrant, no, x would have to be negative beyond negative pi, and that's where y is positive. Well, now that's going to be a negative.
Yeah.
Okay. And again, f of 2x is what?
It's going to be 2 sine 6x.
And 2f of x is going to be what?
That's going to be 4 sine 6x.
Okay. I think you got those down. In fact, I think you got all 5 of these down.
Yeah.
18 is just a more complicated version of 16.
Yeah, I think I could figure 18 out.
Yeah, it's really no different, just one polynomial degree higher.
Okay.
Have you sent me your thing? Yes.
Yeah, I did.
Hold on here. So you start school tomorrow?
Yeah. I actually had to get my schedule changed today and get a parking pass, which took like 3 hours.
Wow.
Yeah. Since they're assigning parking passes, everybody was trying to, or
Where
assigning parking spots.
you go to East?
Yeah.
Wow.
They started assigning parking spots in the parking lot, and so there were like 300 kids in line getting parking passes today.
I bet that was
It was awful.
So
Yeah.
if f of x is sine x, graph f squared. Are you supposed to be able to do all this without a calculator, or is this?
No, I think she says we can. I think she says in the beginning.
Yeah, because I'm not sure that most people are taught how to graph sine squared. Since numbers get smaller, boy, I'm trying to figure out what sine squared would look like. I can pull it up and graph it. But if this is a calculator problem,
Yeah, I think they're all calculator problems.
what is f squared then? What's the function f squared?
The function would be sine squared x.
Right?
Squared.
And notice that that is not the same as this. They are different things. One is sine x times sine x, and the other is sine of x squared. Completely different. So g squared is just the same thing, cosine squared of x. What's f squared plus g squared? In other words, and that might seem trivial to ask, but what is this equal to? It's a common trig identity. Probably the one you want to memorize the most.
Hold on, sorry.
It's equal to 1.
Tan squared, tangent squared.
No, it's equal to 1.
1. Yeah, that's right.
It's always 1, no matter what x is. X can be 10 degrees, x can be 30 degrees, x can be 179 degrees, and this is still true.
Yeah.
Okay. How am I going to find the point of intersection between these two functions? How do you find the point of intersections between functions?
You make them equal to each other.
Exactly. And that will tell you what value of x where the y is the same.
Yeah.
And what do we have? We have 7x equals minus 4. So x equal minus 4/7. That's the point where they intersect.
Yeah, that's...
Remember, what we're looking at here is two linear equations. In other words, the first one I could approximate with that. The second one I can approximate with that. So this point right there is minus 4/7 on the x-axis. Okay, this is basically the same thing, only they want the coordinates, not the single x value. They want the x and the y value. Well, getting the y value is relatively easy once you get the x value because you just plug it in. In other words, the y value is going to be the g of x. But first of all, if I set these equal to one another, and then solve, what's the first step in solving?
Factor.
when you're dealing with quadratics, remember the first step is almost always to get 0 on one side.
Yeah.
It doesn't do any good to factor that if this is not 0. Remember that. Because the only reason factoring is worthwhile is because if you can say that product something times something else is equal to 0, then you can set each one of those things equal to 0 because one of them has to be 0. But if I were to factor this and say that it's equal to 3 minus 2x, I can't say anything. So the first step is to get everything on the same side. Naturally, they're going to give us one that's hard. Did I make a mistake here? What do I do now? I can't factor that with integers. What's the next step?
Quadratic formula.
Which is?
Negative b plus or minus the square root of b minus 4, b squared minus 4ac all over 2a.
Go ahead and substitute for this.
So it would be 3, wait, is it
3 is correct. Minus b is a positive 3.
Yeah, 3 plus or minus the square root of 9 minus.
And I always recommend spelling each of these out like this.
Yeah.
Because it's extremely easy to make a mistake on your sign. And so when you spell it out like this, you're not going to make that mistake. Because what you're going to do is that part first always.
Yeah.
So what does this equal? 3 plus or minus square root of 5 over 2?
Well,
did I do that right?
Wouldn't.
I did not do it right. Excuse me.
Yeah, I thought it would be
13.
Yeah.
Wow. It's been a long summer break.
Yeah.
That's why you do this first, is so you don't make that mistake. Because this clearly gives you a minus 4, and then you're subtracting a minus 4.
Yeah.
Okay. So this appears to give me 2 answers. Should I have 2 answers?
Yes.
Yeah, I have a quadratic, which is a parabola. I don't know if I've drawn it correctly, but if I intersect that with a straight line, which is this part, I get 2 points of intersection.
Unless it's a tangent or they don't intersect.
Well, you're right. If it was a tangent line, then this would have come out to be 0.
Yeah. Hold on,
and
sorry.
I would have only had one solution.
My brother's calling me. Hold on, sorry.
Sure.
Hello? Yeah. No, tell him to walk. I'm gonna be there at like 3:15, so you might as well walk too, and I'll give you your stuff. All right, see ya. Sorry about that.
All right. And let's see, I didn't draw that picture very good. It's a negative slope there, and it goes through 3, so it must be something like that. But normally when you have a quadratic equal to a linear, you're going to have 2 solutions. Because this converts into one quadratic, and a quadratic generally produces 2 solutions. So if it happened to be a tangent line like that, where it intersected, but only at one point, that can only happen if this is 0, if the discriminant is 0. And then it eliminates the plus or minus, and you'd only have 3 halves.
Mm-hmm.
All right. Now, in terms of finding the coordinates of any points of intersection, we didn't quite finish that problem.
You just plug in the x values into one of the.
Yeah, the simple one.
Yeah, but I would.
In other words, the 3 minus 2x.
Yeah.
And whatever that g of x value is, that's the y coordinate for the plus. Plug in the same value for the minus solution.
Yeah.
Get the y coordinate of that. If you look at my picture, you can see that we have a different x coordinate and a y coordinate on both points of intersections.
Mm-hmm.
So that's what we would expect. Unless we had a horizontal line like that, but then that would have been evident by it would have been y equal 2 or something as one of the equations.
Yeah.
What's the graph of y equals sine of 2x look like?
It's just going to be it has a horizontal shrink, so it's going to be like sine of that.
Period going to be?
Pi.
Right. Okay, so now all we have to do is draw the curve between that.
Mm-hmm. And then there's going to be 10.
0.1x has a slope of what?
Has a slope of 0.1.
Okay.
Positive.
Has a y-intercept of what?
0.
Slope of 0.1 is extremely flat.
Yeah.
Okay. However, notice that my sine of 2x goes on forever.
So there's going to be like...
There's going to be multiple points of intersection.
Yeah, until they get past x equals 10.
You got it, because sine of 2x is never going to be greater than 1, and it's never going to be less than minus 1.
Yeah.
So the moment x gets to 10, the y value becomes greater than 1. Or the moment it gets less than negative 10.
Yeah.
So inside the range 10 to negative 10, there's going to be multiple points of intersection, and we'd have to figure out, it wouldn't be that hard to do. Pi is 3.14. And it looks like it goes through once, twice, 3 times. You might have to be a little more precise, but probably not, because 10 is more than 3 times that.
But less than 4 times that.
But less than 4 times that, and that might matter. I don't know. You might want to do that on a calculator and just make sure your horizontal scale goes to 10.
Mm-hmm.
And then you should be able to just count how many times it intersects it.
Mm-hmm.
We could probably figure it out algebraically. Although, oddly enough, we don't have algebra to solve this. We don't know how to solve that algebraically. That is a polynomial combined with a transcendental function.
Yeah.
We don't know how to solve that. The only way we'd solve this is put in your calculator, this side is y sub 1, this side is y sub 2, and their point of intersection is the solutions.
Yeah.
As long as you let your x-axis go from minus 10 to 10, you'll be all right.
All right.
All right. How much time do you have? I have an appointment at 3:30. I can do whatever you need to do here.
Yeah, I'm actually gonna have to get going here pretty soon.
Okay.
I have tennis practice at 3:30 or
We
3:15.
Okay. We can stop now, and we'll just remember, if we have time to go over the rest of this, that we need to start at 23.
Okay.
All right? Okay, Lucas.
All right.
Talk to you later. Bye-bye.
Bye bye.